Hello, good day everyone. My name is Mayan Gamora Guido and I will be presenting to you the timeline of the history of mathematics in ancient period. So there are questions that came into my mind like when and where did mathematics begin and who are the mathematicians who contributed the concepts of mathematics. So as we go along in this discussion, we will be able to answer that questions. So let's start with the Ishangu bone. The Ishangu bone is possibly the oldest mathematical artifact still in existence. It was discovered in 1950 in the Democratic Republic of Congo in Africa and is named after the region where it was found. It dates back to the Upper Paleolithic period of human history and is approximately 20,000 years old. The bone is 10 centimeters long and contains a series of notches, which many scientists believe were used in counting. The grouping of the notches might even suggest some more advanced mathematical understanding like decimal numbers or prime numbers. As you can see here in the picture, this is the Ishagu bone. Mesopotamian accounting tokens. In ancient Mesopotamia, almost 10,000 years ago, scribes and merchants started using small, three-dimensional clay objects as counters to represent certain quantities, units, or goods. Thousands of these were found on archaeological sites across the Middle East, like this from Tepe Gawra in Iraq from around 4000 BCE. The cone, sphere, and flat disc were used to represent small, medium, and large measures of grain. The tetrahedron probably measured the amount of work done in one day. These two tablets, as shown here in the picture, were created around 3200 BCE and used a more advanced technique. So the counters were pressed into the clay while it was still soft to create a record. So that's the way nga sa ilahang pag-record. So the counters were pressed into the clay while it was still soft. Mesopotamian tablets. This is the oldest known clay tablet with mathematical computations. It was created around 2700 BCE in Sumer. So Sumer was one of the earliest civilizations that flourished in the Middle East. It shows a multiplication table in cuneiform which have been used by students, scribes to learn mathematics. Next is the Sumerian multiplication table. So this tablet shows a multiplication table that was created around 2600 BCE in the Sumerian city of Shuruppak. It is one of the oldest mathematical tablets we have ever discovered. The table has three columns. So as you can see here in the picture, there are three columns. So the dots in the first two columns represent distances ranging from around 6 meters to 3 kilometers. So the third column contains the product of the first two, which is the area of a rectangle with the given dimension. So next, Sumer was a region of ancient Mesopotamia in the Middle East. They invented cuneiform as one of the earliest writing systems. So we must take note that cuneiform is one of the earliest writing systems. And by pressing small wedge-shaped markers into clay tablets like this one. So they also developed the base 60 number system. The Babylonian area tablets. These two clay tablets from the Yale Babylonian collection were created between 1800s or 1000 800 and 1600 BCE and contain exercises by student scribes to calculate the area of different geometric shapes. So the first clay tablet is what we call the tablet YBC 7290 or YBC 7290. It shows how to calculate the area of a trapezoid by multiplying the average of the bases and the average of the sides. So the second tablet is what we call the tablet YBC 11120, and it shows how to calculate the area of a circle using the approximation pi equals 3. The Babylonian tablet or the Plimpton 322. So this Babylonian clay tablet called Plimpton 322 was created around 1750 BCE in Sumeria during the reign of Hammurabi the Great. So it was the reign of Hammurabi the Great which this Babylonian clay tablet was created in Sumeria. So while more than 1,000 years older than Pythagoras, the rows and columns on this table contain Pythagorean triples, integer solution for the equation a squared plus b squared is equal to c squared. So for example, 3, 4, and 5 is the Pythagorean triple because 3 squared plus 4 squared equals 5 squared. So the YBC 7289, this circular tablet from the Yale Babylonian collection called YBC 7289 was created around 1800 to 1600 BCE in ancient Babylon. So it shows the geometric diagram of a square with its diagonals. So the tablet shows the Babylonian scribes knew Pythagoras' theorem more than 1,000 years before Pythagoras was ever born. They were also able to calculate square roots and had an estimate for square root of 2 accurate to 6 decimal places. So it is the highest computational accuracy ever seen in the ancient world. The Rhind Papyrus. So the Rhind Papyrus is one of the most famous mathematical documents from ancient Egypt. So we must take note that it is one of the most mathematical documents from ancient Egypt. So it was written around 1550 BCE by a scribe called Amose, who is maybe the earliest contributor to maths in history, whose name we still know today. So as you can see here in the picture, this is the Rhind Papyrus. So the Rhind Papyrus is around 2 meters long and contains 84 problems about multiplication, division, fraction, and geometry. It was probably used as a kind of textbook by other scribes. Next is the Tomb of Mena. Mena was the chief scribe in ancient Egypt and in charge of measuring the size of fields for farming. So inspected crop yields, reporting to the Pharaoh's Central Field Administration, and calculating taxes. So as you can see here in the picture, the wall paintings in his tomb show the different measuring and calculating techniques used more than 3,000 years ago. So for example, in the first row, you can see how long distances were measured using ropes with knots and regular intervals. The tomb was built around 1420 BCE in the Valley of the Kings. So let us proceed to the different mathematicians who contributed the different concepts of mathematics. So let's start with Thales of Miletus, 624 to 546 BCE. He was a Greek mathematician and philosopher. Thales is often recognized as the first scientist in Western civilization. We must take note that Thales was recognized as the first scientist in Western civilization. Rather than using religion or mythology, he tried to explain natural phenomena using a scientific approach. He is also the first individual in history that has a mathematical discovery named after him, Thales theorem. So Thales theorem. Next is Pythagoras of Samos. I know that we are quite familiar with who Pythagoras is. So Pythagoras was a Greek philosopher and mathematician. He is best known for providing Pythagoras' theorem, but made many other mathematical and scientific discoveries. Take note that he is best known for providing the Pythagoras theorem. Pythagoras tried to explain music in a mathematical way and discovered that two tones sound nice together if the ratio of their frequencies is a simple fraction. So Pythagoras tried to explain music in mathematical way. He also founded a school in Italy where he and his students worshipped mathematics almost like a religion. See? Pythagoras worship mathematics almost like a religion. So we could say that Pythagoras is really of fun of kaning like converting or something like worshipping mathematics like a religion. So Zeno of Elea, 495 to 430 BCE. He was a Greek philosopher who is known for his famous paradoxes which have fascinated mathematicians for centuries. So one example is the paradox of motion. So imagine that you want to run a 100-meter race. You first have to run half the distance, which is 50 meters. So, and then 50 meters, you have to run quarter of the distance. So, it will become 25 meters. Before running a quarter, you have to run 1 over 8, 1 over 16th, and so on and so forth. So, this is an infinite number of tasks, which means that you'll never arrive. Okay. So, the Greek mathematician Democritus, 460 to 370 BCE, may be the first person to speculate that all matters was made up of tiny atoms and is considered the father of modern science. So he also made many discoveries in geometry, including the formula for the volume of prisms and cones. So we must take note that Democritus made many discoveries in geometry, including the formula for the volume of prisms and cones. So, next is Plato, 425 to 347 BCE. He was a philosopher in ancient Greece, and together with his teachers Socrates and his student Aristotle, laid the very foundation of Western philosophy and science. So Plato founded the Academy of Athens, the first higher learning institution in the Western world. His many writings on philosophy and theology, science and mathematics, politics and justice make him one of the most influential thinkers of all time. So Plato became one of the most influential thinkers of all time because of his many writings on philosophy and theology, science and mathematics, and politics and justice. So let's proceed to Eusebius of Cnidus. So he was an ancient Greek astronomer and mathematician. So among his most enduring contributions to astronomy are his planetary models. So history remembers him as the first to write mathematical explanation of the planet. So he was the first to write mathematical explanation of the planets. Very interesting, right? So he developed the method of exhaustion in mathematics, which laid the foundation for integral calculus. So Eusebius traveled to several places around the Mediterranean to study. So he studied under Plato in Athens, Greece, and under Egyptian priest in Heliopolis. He later returned to Athens to teach in Plato's academy during the time Aristotle was a student. So Aristotle 384 to 322 BCE. So he was a philosopher in ancient Greece. Together with his teacher Plato, he is considered the father of Western philosophy. So we must take note that Aristotle is the father of Western philosophy. He was also the private tutor of Alexander the Great. Aristotle wrote about science, mathematics, philosophy, poetry, music, and many other subjects. His work was highly influential during the Middle Ages and into the Renaissance, and his views on ethics and other philosophical questions are still being discussed today. So Aristotle is also the first known person to formally study logic. So take note that Aristotle is also the first known to formally study logic, including its application in science and mathematics. Next is Pingala. He was an ancient Indian poet and mathematician who lived under around 300 BCE, but very little is known about his life. He wrote the Chanda Sastra, where he analyzed Sanskrit poetry mathematically. It also contained the first known explanations of binary numbers, Fibonacci numbers, and Pascal's triangle. Let us proceed to bamboo multiplication table. Here you can see a set of 21 bamboo strips that were created around 2,300 years ago in China. So it was created in China. So when arranged correctly, they form a multiplication table in base 10, written in ancient Chinese calligraphy. While earlier civilization like the Babylonians created multiplication tables in base 60, this is by far the oldest known decimal multiplication table. So take note that this bamboo multiplication table is by far the oldest known decimal multiplication table, and it looks very similar to what we still use today. Euclid of Alexandria, so around 300 BCE, he was a Greek mathematician and is often called the father of geometry. So we must take note that Euclid is the father of geometry. His book, The Elements, were first introduced Euclidean geometry, defines its five axioms, and contains many important proofs in geometry and number theory, including that there are infinitely many prime numbers. And we will agree in the debate. It is one of the most influential books ever published and was used as textbooks in mathematics until the 19th century. So Euclid taught mathematics in Alexandria, but not much else is known about his life. So the Euclid's Elements around 300 BCE, it is the collection of 13 books that contain mathematical definitions, postulates, theorems, and proofs, and covering topics like geometry and number theory. So it is one of the most famous books. We must take note that the Euclid's Elements is one of the most famous books ever written, and one of the most influential works in the history of mathematics. So copies were used as textbooks for thousands of years and studied all around the world, with thousands of new editions published. So there is no original copies of the Elements still exist today. So it is part of the Oxyrhynchus papyri, which were found in 1897 in an ancient rubbish dump in Egypt. So the diagram shows, as you can see here in the picture, the diagram shows the fifth proposition in the book 2 of the Elements, a geometric version of the identity, which is the quantity of x plus y times the quantity of x minus y is equal to x squared minus y squared. So let's proceed to Archimedes. So Archimedes, 287 to 212 BCE. He was an ancient Greek scientist and engineer, one of the greatest mathematicians of all time. He discovered many concepts of calculus and worked in geometry, analysis, and mechanics. While taking a bath, Archimedes discovered a way to determine the volume of irregular objects using the amount of water they displace when submerged. So he was so excited by this discovery that he ran out of the street, still undressed, yelling Eureka. So nat, natawa lang ako kay Archimedes. Okay, so let's proceed to Eratosthenes of Cyrene, 276 to 195 BCE. He was a Greek mathematician, geographer, astronomer, historian, and poet, so spent much of his life in Egypt as head of the Library of Alexandria. So among many other achievements, Eratosthenes calculated the circumference of the earth. Very interesting, right? And measured the tilt of the earth's axis of rotation, estimated the distance to the sun, and created some of the first maps of the world. He also invented the sieve of Eratosthenes, an efficient way to calculate prime numbers. Okay, let's proceed to Apollonius of Perga, 200 BCE. He was a Greek mathematician and astronomer best known for his work on the four conic sections. So we must take note that Apollonius was best known for his work on the four conic sections. Suanshushu. From the word Suanshushu, which means book on numbers and computations, is one of the oldest mathematical manuscripts from China. It was written around 200 BCE and consists of 200 strips of bamboo. There are 69 problems, each with a solution, covering topics like arithmetic, fractions, integer factorization, geometric sequences, inverse proportions, unit conversions, and error handling. Geometry problems show how to find the area of circles and rectangles, as well as the volume of three-dimensional solids while assuming that pi equals 3. So as you can see here in the picture, this is the Shuan-Shushu, which means book numbers and computations, and consists of 200 strips. Hipparchus of Nicaea, 190 to 120 BCE. He was a Greek astronomer and mathematician, and one of the greatest astronomers of antiquity. Hipparchus made detailed observations of the night sky and created the first comprehensive star catalog in the Western world. He is considered as the father of trigonometry. Take note that Hipparchus is considered as the father of trigonometry. He constructed trigonometric tables and used this to reliably predict solar eclipses. He also invented the astrolabe and solved different problems in spherical trigonometry. Heron of Alexandria, 10 to 17 CE. He was a Greek mathematician and engineer. He lived in the city of Alexandria in Egypt and is one of the greatest experimenter of antiquity. His inventions include windmills, pantograph, as well as a radial steam turbine called Heliophile or Hero's engine. So Hero's formula allows you to calculate the area of any triangle using just the length of its three sides. So that's Heron of Alexandria. So let's proceed to Nicomachus of Gerasa. He was an ancient Greek mathematician who also spent much time thinking about the mystical properties of numbers. His book Introduction to Arithmetic contains the first mention of perfect numbers. So we must take note that Nicomachus' book titled Introduction to Arithmetic contains the first mention of perfect numbers. Diophantus. Diophantus was a Hellenistic mathematician who lived in Alexandria. Most of his works are about solving polynomial equations with several unknowns. These are now called Diophantine equation and remain an important area of research today. It was while reading one of Diophantus' books many centuries later that Pierre de Fermat proposed one of these equations had no solution. So this became known as Fermat's last theorem and was only solved in 1994. The mathematician and writer Liu Wei on 225 to 295 CE lived during the Three Kingdoms period of China. He might be the first mathematician to understand and use negative numbers. So Liu Wei was the first mathematician to understand and use negative numbers while writing a commentary with solutions for the 9 chapters on the mathematical art of famous Chinese books about mathematics. Okay, Hypatia. Hypatia 360 to 415 CE. She was a prominent astronomer and mathematician in Alexandria. She was also the first female mathematician whose life and work are reasonably well recorded. So she was the first female mathematician whose life and work are reasonably recorded. She edited or wrote commentaries of many of the scientific books of her time and constructed astrolabes and hydrometers. Zhu Chongzi, 429 to 500 CE, was a Chinese astronomer, mathematician, writer, politician, and inventor. He calculated pi accurately to 7 decimal places, a record which was not surpassed until 800 years later. So to do this, he approximated a circle with a 24,576 sided polygon. So Zhu also discovered the formula of 4 over 3 pi r cubed for the volume of a sphere. So his precise astronomical observations allowed him to create a new, more accurate calendar and to predict solar eclipses. So he also calculated that Jupiter take almost 12 years to orbit the sun. Okay, so Aryabhata. Aryabhata 476 to 550 CE. He was one of the first mathematicians and astronomers in the golden age of Indian mathematics. He defined trigonometric functions, solved simultaneous quadratic equations, found approximation for pi, and realized that pi is irrational. Next is Muhammad al-Khwarizmi. So, the Persian mathematician Muhammad al-Khwarizmi lived during the golden age of the Muslim Abbasid regime in Baghdad. He worked at the House of Wisdom, which contained the first large collection of academic books since the destruction of the Library of Alexandria. So, al-Khwarizmi has been called the father of algebra. So, we must take note that al-Khwarizmi has been called the father of algebra. Leonardo Pisano, commonly known as Fibonacci. He was an Italian mathematician and best known for the number sequence named after him. So, like Fibonacci is also responsible for popularizing the Arabic numerals in Europe, which was still using Roman numerals in the 12th century CE. He explained the decimal system in a book called Liber Abbasi, a practical textbook for merchants. Lei Yi. Lei Yi was a Chinese mathematician. He improved methods for solving polynomial equations and was one of the first Chinese scientists to propose that the Earth is spherical. Yang Wei. Yang Wei was a Chinese mathematician and writer during the Song dynasty. He studied magic squares and magic circles, the binomial theorem, quadratic equations, as well as Yang-Wei's triangle, known in Europe as Pascal's triangle. Yang also wrote geometric proofs and was known for his ability to manipulate decimal fractions. Zhu Sijie was one of the greatest Chinese mathematicians. In his book Jade Mirror of the Four Unknowns, he showed how to solve 288 different problems using system of polynomial equations and four variables called heaven, earth, man, and matter. Zhu made extensive use of Pascal's triangle. He also invented rules for solving systems of linear equations predating our modern matrix methods by many centuries. Xuan Yu Dian. Xuan Yu Dian, which means Jade Mirror of the Four Unknowns, is a masterpiece of Chinese mathematics published in 1303 by Zhu Sijie. It consists of four individual books and 288 different problems. So Zhu shows how to solve problems using systems of polynomial equations with up to four unknown variables, the heaven, earth, man, and matter. So to solve some of these problems, Zhu even used the numbers in Pascal's triangle more than 300 years before Pascal was born. So that's all for the timeline of the history of mathematics in ancient period. I hope you get something from it, and thank you so much for listening. Have a good day and God bless.